everyone. In this demo, I'll walk you through how to instrument a chatbot app built with Next.js and the Vercel AI SDK to send telemetry data to SigNoz Cloud using OpenTelemetry. We'll see how to collect these traces from AI interactions and customer interactions and view them in SigNoz Cloud dashboards. Let's dive right in. Here's our sample chatbot, which I've made using Next.js, and it leverages the Vercel AI SDK specifically for LLM responses and streaming output. This use case is a customer service or product support use case where users can ask questions based on the given product or website or company. They can give feedback via thumbs up or thumbs down. In the case where they give a thumbs up, the LLM will respond with additional questions that the user might have to further the conversation or gain more insight about the product. And if they give a thumbs down, the LLM will attempt to regenerate its response to satisfy the customer's needs. Let's go ahead and start. Let's say in this case, I as customer want to know more about the product. We get a nice streamed response from the LLM. And let's say in this case, I'll give a feedback of thumbs up. Here are some additional questions that I might be asked. I can also further proceed, or in this case, I'll just say thanks. Now let's start a new chat and go over the thumbs down feature. Let's say I want to help to find the documentation. In this case, I wasn't too happy with that response. It wasn't in detail enough. Give a thumbs down. It gives more um, information about online support portal, the specific URL. That's pretty helpful. Now let's say I say thanks a lot. So that was essentially how the interaction works. Pretty simple, but it's a perfect use case for observing AI behavior through tracing. So now let's talk about telemetry. The Vercel AI SDK supports telemetry hooks, so we can capture useful metadata during these interactions, like message content, response time, and user feedback. In this case, if we scroll down in our route.ts, we have a stream text function. And this is the Vercel's AI SDK's function, which allows to actually stream that response in that stream-like fashion, one chunk at a time. In this case, we're using GPT 4.1 Nano in our messages array. And here is the crux of actually enabling telemetry. You will pass in an experimental telemetry parameter and set the is enabled hook to true. This is what allows Vercel to actually log and export data using OpenTelemetry protocol. Now let's hook it up onto SigNoz and actually export that data to our SigNoz cloud platform. If you go over to instrumentation.ts, first you want to make sure that that is in our root folder of our project and import Vercel Hotel as well as OpenTelemetry API. And this process is very simple. All you have to do is export a function called register. And this instrumentation.ts file and the register function from that file is automatically detected and executed upon execution of this program by Vercel and by Next.js. All we do is you instantiate a register OTel service, give it a service name. In this case, it's going to be Vercel Chatbot app, and pass in a trace exporter with our URL. In this case, since I'm in the Indian region, we'll pass it in .in to v1 traces. And this is what actually passes the traces onto our platform. As well as we make sure to pass in a header with our SigNoz ingestion key. And in this case, I have a .env.local file over here, in which I have my SigNoz key over there. Additionally, I've set up logging in this. So in a library folder, lib, I've created a logging.ts in which I import OpenTelemetry API, OpenTelemetry SDK logs, exporter logs, OTLP, HTTP, and API logs. And here I set up a log exporter. Again, the same thing as previously, URL and headers with the SigNoz key. The only difference being instead of v1/traces, we're passing it into v1/logs over here. Then using that info, we create a new logger provider. We set that as the global logger provider. and we give it a name. In this case, we'll also give it Vercel Chatbot app. And then we're going to actually export that logger object that's produced from over here. This is very important because in our route.ts again, what you can see is I've imported logger from that library folder. And now we're able to use that object to emit logs. When you call emit on that logger object, you can pass it in any type of JSON-like body, and these will actually be tracked in the attributes in our log section over on SigNoz. Let's jump into SigNoz Cloud and see what's being captured over here. First, I'll go over to logs just to see. Let's do the last minutes. As you can see, these are the type of, let's go last 15 minutes to see more logs. These are the logs of the interactions that we just had from our chatbot. As you can see, they received a post request. At first, the user asked the initial question, tell me about product X, which is what I did in my first example. As well as in the second interaction, you can see I had asked the initial question, where can I find help documentation? We also keep track of useful information such as user feedback. So in this case, we gave a user feedback of thumbs up, versus in the second one, we gave a user feedback of thumbs down. There's also some overall action information, such as receiving a post request, as well as receiving a response from the AI. As you can see, in terms of response, we see that it hit the API chat endpoint, as well as if you look at a sample post request, we can see the exact user message. For example, over here, we can see the user message that was sent. Now let's go ahead and check out traces. And here's where we see all the specific information that's being sent from Vercel AI SDK related to our AI interactions. So if we go to a specific trace over here, as you can see, all of them have the service name Vercel Chatbot app, which is what we instantiated in our code. We can go ahead and check an event over here, a trace over here. And as you can see, these traces are split up into multiple spans. All of these are organized and emitted properly by Vercel AI SDK. All we had to do is enable that flag, like I talked about earlier. You can see the different spans in this trace, which is a post route, resolving the page components on the front end, actually executing that route on the back end, and streaming the text, as well as actually starting the response, which is the action of actually giving the response after the response was generated from the LLM, streaming it back to the user. Some really important and nice information that Vercel provides over here is if you look at x.doStream, we see various AI specific, LLM specific attributes that should be tracked for metric purposes from a developer standpoint. We can see the model ID that was given as well as the model provider that was used. We can see the prompt message format. In this case, it was messages. We have a list of the history of messages since the beginning of the conversation, where the last message will be in this case, you see it's thanks a lot. That will be the last message that I sent, since this is the most recent trace that I clicked on. We can see two different latency metrics. One is milliseconds to first chunk, which is the time it takes for the LLM to generate the first chunk of our stream, as well as milliseconds to finish, which is the time it takes for the LLM to finish the entire stream and send that last chunk over. We also get information about the output, so we can see the output that the LLM gave, as well as prompt tokens and completion tokens. And this is very important for token usage and just keeping track of how many tokens are used by the LLM in terms of both from the input side from the user as well as the completion tokens, which is the output tokens from the LLM. And finally, we also get nice visualized event components for that first chunk and stream.finish events. So Vercel actually handles these and exports them as events as well as attributes in our traces. So as you can see here in our stream, it takes this long, and we have these little blue diamonds, which are events for each of these beginning and ending. We can also see here, I'll go over related logs. In Vercel, by default, logs are automatically linked to traces. This is really helpful where within a specific trace, we can go to related logs and we can see all the logs that have been emitted by me in that specific trace. As we can see here in this specific trace that I clicked on, I had said, thanks a lot. This was the ending of the conversation, essentially. You can see it was received with the post request, and then we can see that we received a response from the AI. Another log over here. So in this case, it would be only two logs, one for uh, sending a reply, and one is for getting a response. Obviously, if we had clicked on other traces, we would be able to see the ones with the feedback given, as well as the ones with the starter messages. We can also create dashboards to monitor metrics like average response time, number of chats, error rates, token usage, etc., um, and analyze these metrics in real time, taken from the traces and logs. I'm going to go ahead and show you. Let's jump right in. On SigNoz, you can see there is a dashboards tab. So let's go ahead and click that. And here is the Vercel chatbot. This is just one that I made in preparation for this video. As you can see here, there's a lot of useful metrics that we might want to take notice of from a developer perspective when you're creating your own LLM chatbot. Over here, we can see there's total input and output tokens taken over the last 6 hours. And this is really important for monitoring usage as well as payments for API tokens. Here we can see the overall feedback that's given by the users. So in this case, we have 2,086 total feedback given in the last 6 hours, and approximately 75% of that was thumbs up versus 25% was thumbs down. And you can really use this to kind of customize your LLM feedback. If you're getting more thumbs up, then you know the output that you're given is good and it's actually being appreciated by the users versus if there was more downvotes, then you know there's some room for improvement over there. We also have a convenient panel called starter message distribution. So those first four starter messages that you could have selected from in our example earlier, we see here that the distribution is almost 25% each. So in this case, the customers have been selecting evenly all these starter messages. But in cases where you have an overwhelming majority of one specific starter message, you know where to focus your efforts on to kind of refine the articles for that specific starter message or just refine the information that the LLM is producing for that specific starter message. But in this case, we'd want to refine all possible values or all possible starter message articles because this would be useful and evenly tracked by all the users. Then over here, we see a tokens per second generated over the last 6 hours. This is kind of a line time series chart. And we see that basically all the values are ranging from about 1 to 4 tokens per second. This can really be used to see and monitor how efficient our LLM is being. And lastly, over here, we have two metrics related to latency. We see the overall latency over time. And as we can see, there's a small spike over here that goes all the way to a whopping 10,000 milliseconds, which is 10 seconds of latency. But generally, we're very, very little latency. And from this perspective, we can see here that that peak happened on 1550, which was about a couple hours ago. And from a developer's perspective, we could go and monitor the logs and traces that were happening around that time to kind of debug what exactly was responsible for that high latency. As well as lastly, we have a custom threshold value in which we're filtering all the responses for any responses that have greater than or equal to 1,000 milliseconds or 1 second of latency. Here we see that we have 5.78% of our total requests that are having this more than a second latency. And in this case, we see that it's an orange value. What's really neat is if we look into editing this panel, we can set different colors codes for different threshold values. So I set it up so that if it's more than 5%, it would be orange. But if it actually increases to more than 10%, it would be red. We can really use this to easily visualize um, how latent our system is on average. And in this case, it's in that orange realm where it might need some fixing, but luckily it's not in the red uh, more than 10%. So that's a quick end-to-end demo of how to build a chatbot using Vercel AI SDK, how to collect telemetry during these user interactions, how to export data to SigNoz Cloud using OpenTelemetry, and visualizing it and analyzing it in real time using the traces and the logs panels as well as this dashboard panel. Thanks for watching and hope you have a great day.